This question is about pentan 2-ol and pent-1-ene. The boiling point of pentan 2-ol is 119. The boiling point of pent-1-ene is 30. So this is highest. Explain why pentan 2-ol has a higher boiling point than pent-1-ene. So pentan 2-ol, pent-1-ene. So this has got an OH, so pentan 2-ol has got an OH, which means it's going to do hydrogen bonding. So hydrogen bonding, all we've got to state with it is between molecules. And pent-1-ene, so this is a non-polar molecule, so this is going to be van der Waals forces of attraction. Between molecules. So 1 mark for each of those, and then I just need to do a comparison here. So the hydrogen bonds are stronger than, so if I put VDW here, I can now abbreviate from here, than van der Waals, therefore more energy required. Okay, so there's your 3 marks there. Part B, pent-1-ene is formed by the elimination of water from pentan 2-ol. Outline the mechanism, state the reagents and conditions. I'm going to start with the mechanism, and we'll go back to look at the reagents and the conditions in a minute. So pent-1-ene is formed from pentan 2-ol. So 1, 2, 3, 4, 5. I'll put my OH on here, and then I'll display around here, and I'll display here. But with these here, I'm just going to do CH2, and then just to make this a little bit shorter, CH2, CH3 I'm going to put there. Okay, so the elimination of water, so the OH is going to come off, but it will either come off with that hydrogen there, or it will come off with this hydrogen here. And you've got to have a look at the question to see which one of those two is going to come off. So it's forming pent-1-ene, which means the double bond is going to form here. So when you take your OH and your hydrogen off, you're taking these ones off here, okay? Or probably a better way to look at this is to say the hydrogen has to come off that carbon there, okay? So let me just tidy this up again so that now that we know what's coming off where, okay? So let's do the mechanisms. Let's put my H plus on here. Let's put my lone pairs on my OH here, and let's start with the mechanism. So curly arrow from the lone pair on here. To there. Which gives me my intermediate, so H, C, H, H, C, H, and then, now I know it's not these, I'm going to do CH2, CH2, CH3, and then I've got OH2 with a plus on here, and then my next step is the curly arrow from this to there, and from this to here, and this is the elimination of water. So that gives me my final product. If I go down here, so that's where my double bond is now. The water has gone, so I've got my hydrogen here, CH2, CH2, CH3, and you can see here that I have made my pent-1-ene. Okay. So the reagent here for this, you can have concentrated phosphoric, Okay, concentrated is required, or you can have concentrated sulfuric. Either of those are absolutely fine, but the concentrated is absolutely required. In terms of the condition, you need a high temperature. So 1, 2, 3, 4, 5 marks for that question there.